Hello everybody, welcome to today's topic of remainder and factor theorem. So first of all, let's look at polynomial identities. So this sign is basically an identity which shows that both sides of the equation are equal and we have to find the values of coefficients which are a and b in this case. So let's make space for this. Okay, so in identities you cannot move stuff here and there, so you have to work within that identity. Okay, so first of all we'll have to open this. uh, so this will give us ax cube minus 3x square plus bx minus 3ax square plus 9x and minus 3b. Okay, and this is equals to x cube minus 6x square minus x plus 30. Okay, so now we'll have to equate the coefficients. So first of all, let's take x cube. So over here we only have one x cube, and over here we have this, which is ax cube. Okay, so now we'll solve for a. That gives us as a is equals to 1. Okay, now let's take the square. So minus 6 over from this side will be equals to minus 3x square minus 3ax square. These are the two. So we can take x square over here and x square over here common. And we can cut these. So that will leave us with, but because we already have a, this doesn't really serve us a purpose. So again we're getting a as 1, but we don't need this, so I'm gonna rub this out. Then we're gonna solve for x. So if we solve for x, we have this one b, so we have minus x here and we have a bx plus 9x over here. So again we can factor the x out. So b plus 9 is equals to minus 1 and b is equals to minus 10. So here we have the values of a and b, and this is how you can solve polynomial identities. Now let's do another question of this. Okay, so you'll see a similar question a lot of times in the past papers. You'll first have to open this x square minus 2xp plus q square plus r px square minus 2xpaq plus pq square plus r. Okay, so now that we've opened this, now we can equate them to the coefficients. So we'll equate the coefficients of x square. We can skip writing x square because it's gonna cut. So we get 3 as p because there is only one x square in both equations. Now let's take the x's in both equations. So again we have only one. So minus 2 pq is equals to 6. We're not taking the x. We have found the value of p, so we can put that, and this gives us minus 1. So we found the value of q as well. Okay, so for the value of r, we can take minus 4 equals to pq square plus r, because both of these values do not have an x, so both of them are a constant, so we will equate them to this constant in this equation. Okay, so minus 4, we have the value of p as 3 and the value of q square would be 1 plus r is equals to minus 7. Okay, so now let's take a look at remainder theorem. So if a polynomial is divisible by a linear divisor, so the remainder is equals to when you put that a into the polynomial. So for example, in this equation we have fx is equals to 4x cubed minus 5x plus 1. So the question will say when it is divided by x minus 2, find the remainder. So you have to find the remainder when you're dividing this by x minus 2. So what you're doing basically is x divided by x minus 2, and you perform this division. But this method we will do later. This is called long division. Right now we're going to do a shortcut. In this, what we do is basically we solve this for x. We find the value of x, which is 2. We substitute this value in the equation, and the result we get is the remainder. So this is what we've done over here. We put 2 as the substitute, and we have the remainder, which is 23, which is the remainder we get when we divide this equation by x minus 2. Okay, now let's do a question of this. Okay, so in this question it says that this is the fx, and it leaves a remainder of 3 when it is divided by x minus p, and we have to find the value of p. So in this question they've given us the remainder, which we had to find in the previous question, and they're asking the value of the divisor. Okay, so again we're gonna solve for x, so we get the value of p. So we do 6p square minus 2p plus 3, and this is the remainder we get when we divide this by this. So it's given in the question that this is equals to 3. So 6p square minus 2p, and 3 will get cancelled. So we can take p common, and now we can get the value of p, which is 0 and 1 upon 3. Okay, so in this question it says that use long division to find the answer to this. So what is long division? It is the type of division we do when we're dividing two numbers, but in this we will have variables in it as well. So we have 3x to the power 4, 5x square and 4, and it is divided by x square plus 2. So similarly we multiply this thing with something which could cancel this out, this thing out. We forget this for a second, and we find out what can eliminate this. So to take out this, we have to multiply it by 3 and then with x square. So this would give us 3x to the power 4, and because normally we put a minus sign over here, so we'll put a minus sign over here as well, but we'll multiply 2 with this as well. So we'll get 6x square, but because there's a minus here, this will affect this as well, so it will become minus 6x square. Alright, okay, so this will give us 0 and this will give us minus 11x square. Okay, now we have to cancel this thing out. This 4 will come down here. We have to cancel this thing out. Okay, so now for that we have to multiply, we have to actually bring the same thing, because the minus will make it positive, so we have to bring minus 11x square. So we will multiply it by minus 11. So minus 11x square, which will give us minus 11x square minus 22, and because of the negative sign both of these things will become plus. So this will become 0 and this will become 26. So this is the remainder we get when we do it this way. Okay, so if we do it with the method we were doing before, we can take x square as minus 2, But if we put square root on both sides, we can't put a square root on something which is negative. So we will just take x square as minus 2 and put it into the equation, because in this equation we can put it like that. So 3x square, that means that 3 minus 2 square minus 5 into minus 2 plus 4. This will give us 12, this will give us plus 10, and this will give us 4, which again makes 26, equal to this. Okay, now, so what is factor theorem? So in factor theorem, when something is divided by a linear equation, the remainder is 0. That means that it is fully divisible. So in this question, it says that x minus a is a factor of this equation. That means that the remainder will always be 0 when something is a factor. So we have to express b in terms of a. So again we will solve for x, and get a. So 2a square plus ba minus 3, and because this gives us the remainder and it's a factor, so the remainder will be 0. So we have to express b in terms of a. So ba is equals to 3 minus 2a square, and b is equals to 3 minus 2a square upon a. So you can solve a factor theorem question like this. Okay, now let's move forward to solving cubic equations. Okay, so to solve this, you'll need your calculator. In some calculators, there might not be this option. So for them, I will tell you later what you can do. So in your calculator, press menu and then press A or go down and find equations and functions. Then select polynomial and select the degree of the equation you have. For example, in this question, we have the degree 3, the highest degree. Okay, now enter the coefficients. For example, I will put 1 in x cube, minus 4 in x square, 1 in x, and 6 in the constant. So this will give me all of the three factors, all of the three roots it has. So we will get one of the root. We can note all the three roots down for later, that we can cross check that we've done everything right. But we need one root, and we will show as if we found the root through trial and error method. So to the people who don't have the calculator, they will do it actually with the trial and error method. So in the trial and error method, you will suppose a value of x. For example, we'll suppose that x plus 1 is a factor, and we'll place minus 1 in the value of x, and you will get 0. So that means that x plus 1 is a factor. So for example, I don't have a calculator, and I will first of all put the value minus 1. If that it doesn't give me 0, I will put minus 2, I will put 1, I will put 2, I will put 0, something like that, which ends up giving you 0. And it is normally between these. It'll go max to 3 or minus 3, but no more than that. So you'll just have to try a couple of these if you don't have a calculator. Okay, so if you get this, so you get the first root and you confirm it through this method. You show that 0 is equals to 0 and that x minus 1 is a root of it. So now you will come over here. We'll make a box like this. In this box, we'll write the coefficients of all of the equation over here. So x cube has 1, x square has minus 4, x has 1, and the constant is 6. So we'll write it like this. So the first value will come down like this. You will then multiply this first root. You found this root, so you will multiply it with this one, this value, the first one, and this will give you minus 1. You will write it under the second value. Okay, now you will add these, so this will give you minus 5. Okay, now you will multiply the first root you had got with this value, so this will give you 5. So you put 5 here. Okay, now you will add these values and you will get 6. Okay, now you will multiply this with 6 and you will get minus 6. You will write minus 6 here and this will give you 0. So what are these three values? This basically gives you an equation: 1x square minus 5x plus 6 is equals to 0. So what this is doing is, this is giving you this equation. We have basically broken that cubic equation into a root and a quadratic equation. And now we will simply solve this quadratic equation by equating it to 0. Okay, so we can solve this by 3 and 2, minus 3x minus 2x plus 6 is equals to 0. We'll take minus 2 common here, and this will give us the roots x minus 3 and x minus 2, and the answer for this cubic equation is basically minus 1, 3 and 2, because this will solve to x is equals to 3 and x is equals to 2, and we have x is equals to 1 from here. So these are the three roots of this cubic equation. So that was all from remainder and factor theorem. Thank you for watching. Goodbye.